Hi everybody and welcome to this instructional video about radioactivity. Hopefully this will be of help to you if you missed the lecture or even if you were at the lecture you can use it to refresh your memory. That's the radioactivity symbol there. You may have seen that in hospitals or on the side of lorries and things like this. And here's a list of the topics we're going to cover in this instructional video. By the end of this video you should be able to answer the following questions quite easily and happily. What is radioactivity? What is background radiation? What different types of radioactivity are there? What causes each type of radiation? What are the characteristics of each one? And how dangerous is radiation and why? So we'll start off by talking about why some things are radioactivity. Some substances are radioactive and some aren't, because by no means all substances are radioactive. The substances that are radioactive tend to be from the heavy end of the periodic table, above lead particularly, where the atomic nucleus is so massive that it becomes very unstable and can split apart completely spontaneously, which means completely at random. And what it's trying to do is to become more stable, turn itself basically into another element which is a lot more stable from further down the periodic table, trying to make themselves more stable by throwing things out, basically throwing particles or waves out to make themselves less massive and therefore more stable. Now, you may think some things are radioactive, just things in labs are radioactive, but actually radioactivity is all around us in the form of background radiation. Here's a slide of a few things that are radioactive that you might not realise. Cat litter is mildly radioactive. Brazil nuts are mildly radioactive. Beer, bananas, strip lights, smoke alarms, diamonds are radioactive. And this is the city of Aberdeen in Scotland, which is radioactive due to the rocks that it sits on. And all of these things are constantly in the background and are actually creating quite a high level, relatively high level of radioactivity all the time. Now radioactivity takes three forms, and you need to know, this is particularly what you need to know for the exam, is the three forms that radioactivity takes. There's alpha radiation, beta radiation, and gamma radiation. I'm going to skip this slide. If you want to pause it there, you can do, just to read that, but it's mostly summarised in the next table anyway. So I'm just going to leave that and move on in a second, but you can pause this if you like right here and have a read through that. Okay, here's a table that summarises very much what you need to know for the exam in June, which is for each type of radiation, what its symbol is, what is it made of, physically what is it, particularly the third row down, what can stop it. Almost all the questions on radioactivity in the exam in June are based on what can stop these different types of radiation. And also something called ionizing power. Now the symbol for alpha is that. Looks a bit like a lowercase a. Beta is looks a bit like a capital B sort of, and gamma is that symbol there. All Greek letters of the alphabet, which is why they look a bit strange. Now this next row is about what physically is it. Now alpha radiation, when a heavy nucleus gives out alpha radiation, what it's actually physically giving out is a helium nucleus, 2 protons and 2 neutrons. Again, you see it's trying to make itself less massive by throwing out these particles. A beta particle, when beta radiation is given off, it's actually an electron that's being given off. So that's a particle as well, like alpha radiation is. Gamma is different because that's actually a high energy electromagnetic wave. In fact, you might remember gamma radiation from the electromagnetic spectrum that we did a couple of weeks ago. Now this next row is very important. Maybe rewind the video a few times to really get this, is what can stop these different types of radiation. Alpha radiation can be stopped by a thin sheet of paper or just a few centimetres of air, which makes it less dangerous because all you've got to do is stand a little bit far away from anything that's producing it and you're quite safe. Beta is a little bit more penetrating, as it's called. To stop that, you need a few millimetres of aluminium or a few metres of air. So you have to be standing a fair way away from that, or have something like aluminium in between you and it. Now, gamma radiation, though, is extremely penetrating, and it takes several centimetres of lead or very thick concrete to stop that. Like I say, a lot of the questions in the exam in June are based on this row of the table, so you really need to know this stuff. Ionizing power is how dangerous it is to us, how easily it causes cancer. Alpha is very high because although it doesn't penetrate very far, but when it does, it's extremely damaging inside the body. It can damage your DNA, which is what causes cancer. Beta is sort of medium. Gamma, weirdly, is actually quite low because most of the time it just passes straight through your body, because most of your body is actually nothing. It passes straight through it. If it hits something, it can cause damage, but that's fairly rare. Here's a slide that summarises that. You see alpha at the top there being stopped by just a thin sheet of paper. Beta going through the paper, but being stopped by aluminium, and gamma going through pretty much everything apart from lead. Got it? That's pretty much it for this video. I'll put on below this video on YouTube, I'll put a couple of video links in as well about background radiation and also how dangerous radiation is, which will also add to your knowledge of this subject. So I hope this has been useful, and I'll see you on the next video.